Hello, welcome students to today's lesson 2. Remember we did the part of the circle on our previous lesson and we want to recap on some of the few things. So I want you to label the parts of the circle from A to G in the comment section as we did in our previous lesson. So before we move on to today's lesson, which is the starting of the circles theorem, I want you to go and subscribe to the channel and click on the bell icon to get notification anytime a new material or video is posted. Now we have a number of the circles theorem, but today our objective is to tackle two of them, and that is the angle subtended at the circumference and at the center by the same chord. One of the objective for today. And then the second one is angles in the same segment of a circle subtended by the same arc or chord. So quickly, let's move on to the first objective or the first theorem that we want to talk about, and that is what I call the center theorem. The center theorem. What does this theorem say? So we are saying that the angle at the center of a circle is twice the angle at the circumference subtended by the same arc or chord. So the angle at the center is twice the angle at the circumference. So if we have the chord AB forming the angle at the center and the same chord AB in red dashes forming the angle at the circumference, then the relationship is that 2 times the angle at the circumference will give you the angle at the center. So from the diagram, angle AOB, which is at the center here, A equals 2 times angle APB. So if angle APB is Y, if angle APB is Y, then angle AOB, which is at the center, will be 2y. If the angle at the circumference is y, then the angle at the center is 2y. That is the relationship. And vice versa. If we have the angle at the center to be 2y, then the angle at the circumference is y. So 2 times the circumference will give you the center, and then the center divided by 2 will give you the circumference. That is the first theorem we want to look at today. We will solve examples so that things will be much clearer and understandable. So let's move on to the second one and then we start solving examples. The second theorem that we are looking at today is what I call the segment theorem. What does this theorem says? This theorem states that angles subtended by a chord or an arc in the same segment of a circle are equal. Angles formed or subtended by a chord or arc in the same segment of a circle are equal. So if we have a number of angles formed in the same segment, then this theorem says that those angles in the same segment are equal. So by definition, it means angle ACB equals angle ADB equals angle AEB, and they are all the value of what? M. Simply what we are saying is that if I highlight one of the segments in this diagram, so I'm highlighting this part of the segment so that we will easily look at how this story is going. Good. So now I have this part of the segment shaded in yellow. This theorem states that Now we have two segments. We have the minor segment being shaded in yellow here. Remember we talked about segment in our previous lesson. And then the unshaded part, the white area here, is the major segment. Now all these triangles are formed in the same segment, which is the unshaded segment or major segment. And therefore this one is saying that they are all equal because they are in the same segment. So if the value of this angle at C is 20 degrees, the value at D will also be 20 degrees, and same will be for E, 20 degrees, because they are in the same segment, the major segment, and we have the minor segment in yellow. I hope it's clearly understood. Now let's start to solve examples with these two theorems we've talked about. So example 1 said find the value of each of the pronumerals or letters in the diagram. O is the center of the circle and angle AOB is 100 degrees. So we have our diagram here, and we are going to look at how to find the value of x and then y using the two theorems we've studied. So our solution. Now from theorem 1, or the center theorem we talked about, we said that the center is twice the angle at the circumference. So we have angle AOB, angle AOB, it is 100 here, it being equal to 2 times the angle at the circumference. So 2 times angle AMB, angle AMB, so x here. So we have 100, this 100 equals 2x, because we said whatever is here 2 times whatever is here will give us the angle at the center. So we have 100 equal 2x. Because we want the value of x, now we divide both sides by 2. So we have the value of x as what? 50 degrees. So we can bring it or indicate in our diagram here. So we have the value of x being what? 50. Let's look at how to find the value of y. Now you're left to how to find y. And also from theorem 2, we said angles in the same segment are equal. Angles formed by the same chord or arc in the same segment are what? Equal. So if you know the value of x as 50, then you can say that y equals x because they are in the same segment using theorem 2, and therefore y will also be what? 50 degrees. I hope this is very clear. Now let's look at another example. Example 2. In the diagram, O is the center of the circle PQRS and angle PQR is 65 degrees. Find the value of x. So we have our diagram, we are finding the value of x. We are being given angle PQR at 65 degrees. Let's look at how to use the two theorems we've studied to find the value of x. So we have the center theorem, angle POR, angle POR, that is the angle at O here. The angle at O here is 2 times angle PQR. So the angle at O here is 2 times angle PQR, the angle at the circumference. Mind you, the diagram has been turned, but still the theorem holds. So we have 2 times 65 degrees, making 130 degrees. That is for the angle POR, this side at the center. So let's indicate it there. We have this side as 130 now. But our focus is to find the value of x. So we are interested in finding this x here. But we know that angles at a point from geometry Angles at a point sum up to 360 degrees. And therefore, if we have the known part to be 130 degrees, we can just subtract from the 360 to get the unknown part, which is the x. So we have angle x being equal to 360 minus the known part, which is angle POR. So we have angle x to be 360 degrees minus 130 degrees, and that will give us 230 degrees for the value of x. These are the two examples we will look at in relation to this theorem. I hope it's well understood, and we'll look at the other theorems and how to use them to solve questions or problems. But before that, I want you to subscribe to the channel. Click on the subscribe and then click on the bell icon to get notification anytime new videos or materials are being posted. You can equally also click on the picture and then subscribe and then click on the bell icon. Please remember to leave your questions, concerns, and everything relating to this lesson in the comment section, and I will try as much as possible to attend to them. Thank you for your audience and have a wonderful day.